Welcome back, ladies and gentlemen. We have officially finished exploring our vertex form of the quadratic equation, and now we're going to start applying the different forms to solving word problems. So, as I've said before, if having x's and y's and numbers is really no good unless there's a real life problem that goes along with it for it to make sense, because otherwise we're just doing pointless work to keep ourselves busy if it doesn't mean anything at the end of the day. And yes, I can hear one of you, two of you saying this is pointless work anyways. It really depends on what career you're going to end up going off into in the future. Depending on what you do, you'll use this stuff a lot. Depending on what you do, you'll never look at it again. And so, regardless, you're in this course and you made it this far, let's see it through. At fireworks display, a firework is launched from a height of 2 meters above the ground and reaches a maximum height of 40 meters at a horizontal distance of 10 meters. Write an equation in vertex form to model the path of the firework. So first off, what are we looking for? An equation in vertex form. Okay, so I already know I'm going to try H. I'm going to try and get this. Now, hopefully I have a vertex somewhere, and I do. Where'd we go? 10. And how do I know that it's 1040 and not 4010? Because H is usually Y. And I'd love to say that there's a better reason for that, but really, does height depend on distance or does distance depend on height? Um, you could argue it either way. I've just done this enough that I know that height is usually Y, so I'm setting my equation up that way. Now, before we get too far, let's define those variables. Measured in meters. Also in meters. Okay, but we need a second point, right? We have our vertex, but we got to find a height and a horizontal distance so that we can solve for A, because we know no human being is going to know what A is off the top of their head. We got to find it. And that's where, if we go back to the question, we have a little bit of extra information. So if it's launched, initially, then it must be that its distance equals 0 and the height is 10. So we can turn around and substitute that in. Height of 10, height of 2. And then turn around and solve for A. Now, I do encourage you to work with fractions, but in this case, when you're dividing by 100, it gives you a nice easy decimal, so why not just use that decimal? And there's our equation in vertex form. Now, some of these questions we have seen before. I want you to do them anyways because you may have approached them one way before, but there might be an easier way you have since learned to do it. For example, this question we could actually solve in two different ways. So the profit of high-tech shoe company is modeled by the quadratic relation, blah, where x is the number of shoes. Determine the pairs of shoes the company must sell to maximize its profit, and what the maximum profit would be. So once again, we need to find the maximum value. We got to find our vertex. As of now, we have two options. We could factor, or we could find the partial factor. In which case, we turn around and solve for y. Well, okay, fine, p in this case, since there's no y in this equation. And both methods will work just fine. Um, I'm going to go through and factor it for no reason in particular, just because I can. Now, notice I don't have to define my x and p in this one because the question does it for me, right? The profits, p, and x represents the number of shoes. So I've already been told it's not that I've forgotten that step. The question does it for me. Hmm. So I have to sell 600,000 shoes, right? Because X was the number of shoes. All right, last question. The path of a football after its kick falls, all that gobbledygook, where h is the height in meters, is t in the time to second. So once again, my variables are defined. I don't need to define them. Determine the maximum height of the football to one decimal place and the time when it reaches this maximum height. So once again, vertex. Since I can't factor, must partial factor. So that last question we had the option. This question we do not. So we're going to choose an h value. Wow, I'm writing poorly. And the advantage to factoring out the greatest common factor is that it means that what's left in the brackets is simple to solve. Man, I am striking out. All three of my versions on my sheet are wrong. My apologies if this seems to have jumped. I am going back and forth between screens, and rather than you recording me do that, I'm just coming up with the next answer. So I'm going to put you on pause again, not that you'll notice the difference, and you'll see the next lines randomly showing up. Again, sorry for the jump, but here's the next line. All right, and there is your final answer to one decimal place. So, the question is, max height of 27.0 meters at 2.33 seconds. All right, there is a handout. The homework is on there. And remember, you're looking for either the vertex or the x-intercept. Once you determine which one you're after, you have the tools to do it. All right, guys, have a good one. Make sure to do the review and get ready for the test. Get that assignment into me soon. Bye.